Hello everyone. We continue our discussion on the addition and subtraction trig formulas. 6. Find the exact value of cosine alpha minus beta given that sine alpha equals -4/5 and cosine beta equals -5/8 for alpha in quadrant 3. So alpha is in quadrant 3. And beta is in quadrant 2. So alpha is in quadrant 3. Alpha is around here. So that's alpha. And beta is in quadrant 2. Quadrant 2. Okay, so that'll be a beta right there. Beta. Okay. So sine of alpha, that is y over r. So r will be 5, your y will be -4. So r is always positive. So we need to find x. And we're using this alpha in our triangle, so we could call that alpha prime or alpha reference angle. So remember, x squared plus y squared is equal to r squared. So x squared plus -4 squared is equal to 5 squared. And if we simplify this all down, x would be equal to plus or minus 3, but we would take the negative because we're in quadrant 3. We're in quadrant 3, so we take the negative. So x is equal to -3. So then the cosine of alpha would be equal to -3/5. Let's work with beta. Says that beta, cosine of beta is -5/8, so x is -5. R is 8. Remember that cosine is x over r. So we need to find y. Well, we know x squared plus y squared is equal to r squared. So plug in for x, -5 squared plus y squared is equal to r squared, which is 8 squared. And solve for y, we'll end up with y is equal to, it's a positive because we're in quadrant 2, radical 39. So then the sine of beta is equal to radical 39 over 8. We want to use all these to find the cosine alpha minus beta. We know from our formula that we learned earlier that the cosine of alpha minus beta was equal to cosine alpha, cosine beta, minus, well, that's going to be plus sine alpha, sine beta. Remember with our cosine formulas, you have the minus between the angles, then you have a plus on the right side between the terms on the right side. Okay? So let's plug in the parts we know. Let's plug in the parts we know. Cosine of alpha is -3/5 times cosine of beta, which was -5/8, plus sine of alpha, which was -4/5, times the sine of beta, which worked out to be -39/8. We multiply through and simplify this, we'll end up with 15 minus 4 root 39 over 40. That's our final answer. Right? Let's look at another question. Find the exact value of tan 255, given that we can use angles, let's call them U and V. U is 300 degrees and V is 45 degrees. The formula for tan U minus V is equal to tan U minus tan of V over 1 plus tan U tan V. Plug in what we want the tan of 300 degrees minus tan of 45 degrees over 1 plus tan of 300 degrees times the tan of 45 degrees. And so the tan of 300 degrees was negative radical 3 minus the tan of 45, which was 1, over 1 plus negative radical 3 times 1. Then from here on, it's just algebra. We have negative root 3 minus 1 over 1 minus radical 3. I want to make it look a little bit better, simplify a little bit more, simplify as much as possible. Multiply by the conjugate of the denominator. That's 1 plus radical 3 over 1 plus radical 3. And so at the top, you will have, following this through, you will have negative 4 minus 2 radical 3. At the bottom, you will have 1 minus 3, which is just negative 2. Then we can factor out a negative 2 from the top, so it's negative 2 plus radical 3. And there was a negative 2 at the bottom, so you see this cancels out nicely to just be 2 plus radical 3 as your final answer. Very nice. Okay, let's talk about using inverse functions. Use inverse function to find the exact value of sine of tan inverse negative 9/40 plus cosine inverse of 8/17. Now remember what we know about inverse functions. An inverse function is an angle. Inverse function is an angle. And so let's call this one u. Let's call this one u. And this other inverse function is also an angle. Let's call that v. So what we're looking for is a sine of u plus v, all right? So we know then that u is equal to tan inverse of negative 9/40, and v is equal to cosine inverse of 8/17. So then, from this, we take tan inverse of both sides. We have tan of u is equal to negative 9/40, and the cosine of v is equal to 8/17. Now we have to remember where tan inverse and cosine inverse lives, right? So let's find where u is. Tan of u is negative 9/40. The tangent is negative in quadrant 2 and 4. But because tan inverse only lives on the right side, quadrant 3 and 4, then we choose our angle for u in the 4th quadrant. Okay, so remember that. The reason why we choose in this quadrant is because this is where tan inverse lives. Okay, so we are doing a negative 9 on the y and 40 on the x, right? Because u would be this entire angle, but we take in the reference angle to it. So u is regarded as this angle right here between the line and the horizontal. And we want to find r. And we know x squared plus y squared is equal to r squared. So that would be 40 squared plus negative 9 squared equal to r squared. And if we simplify and solve for that, we end up with r is equal to 41. Right, so r equals 41. Okay. For v, let's work out for v. V has your cosine inverse. Remember, cosine inverse lives here. But then it's positive, so we just focus on quadrant 1. Quadrant 1 of v then is 8/17. 8/17, so angle v is right here. and then that's 8 on your, was your cosine, so that's 8 on your x. You really need to find your y. You need to find a y. So then let's do x squared plus y squared is equal to r squared. X squared plus y squared is equal to r squared. And so we have 8 squared plus y squared is equal to 17 squared. And then we're trying to solve for y, do all this down. When we solve, we get y is equal to 15. Those are positive. And so then what do we want to find then? We remember that sine of u plus v is equal to sine u cos v, right? Sine u cos v plus cos u sine of v, right? Sine u cos v. Okay, so sine of u, let's go back up. Sine of u from this triangle would have been negative 9 over 41, negative 9 over 41. And the cos of u would have been 40 over 41. And from this other triangle, cosine of v was given as 8 over 17. And then the sine of v would have been 15 over 17. And then we plug these in. So we have sine of u, negative 9 over 41. Cosine of v is 8 over 17. Plus cosine of u is 40 over 41. Sine of v would be 15 over 17. And then multiply through and simplify, we end up with 528 over 697. 528 over 697. Recall our cofunction formulas and periodic identities. Periodic identities we met before. Cofunction formulas are the ones we look at now. But cofunctions are really trig functions which give the same result for complementary angles. So complementary angles come from the word, cofunction is from the word co, is from complementary. Right, specifically for the sine, notice the sine of theta is the same as the cosine of pi over 2 minus theta. And for tan, it's pi over 2, is the cotan of pi over 2 minus theta. So sine and cosine, they are cofunction angles and so on, with a difference from angle from 90 degrees. All right, let's look at a quick example. Express the cofunction of a complementary angle, cosine of 9 pi over 8. So the cosine of 9 pi over 8, the complementary angle will be a sine of pi over 2 minus 9 pi over 8. And so that would be the sine of 4 pi over 8 minus 9 pi over 8. And so that would be equal to the sine of negative 5 pi over 8, and we're done. Okay, let's look at another example. Verify the cofunction identity. Sine of pi over 2 minus theta is equal to cosine theta. So what do you want to do? Remember sine subtraction. So sine of u minus v was equal to sine of u cos of v minus cos u sine v. So this is going to be equal to, let's do sine of pi over 2 cosine of theta minus cosine of pi over 2 sine of theta. And so sine of pi over 2 is equal to 1 cosine theta. And it's going to be equal to 0. So cosine of pi over 2 is 0 times sine of theta. And so this is 0, this is 1 times cosine theta, and that gives you cosine of theta, and you're done. And thanks for watching, and we'll do some more later. Remember to